Hello and Assalamualaikum everyone. We will be presenting a video about non-reusable energy, which is nuclear power. It's my pleasure to introduce myself and my teammates. My name is Shazana Zira and this is my teammates Muhammad Sharul and Siti Aisha Iza. Let's begin.
Nuclear power, electricity generated by power plants that derive their heat from fission in a nuclear reactor. It, unlike fossil fuel, it does not burn. Uranium reaction take place that split the atom and release high amount of heat energy. It is called nuclear fission. Nuclear power provides almost 15% of the world's electricity. In a nuclear power station, the heat released from nuclear fission reaction is used to change water into steam. As in other types of power station, the steam then turns a turbine, which turns a generator and produces electricity. Nuclear power reactors do not produce direct carbon dioxide emission. Unlike fossil fuel-fired power plants, nuclear reactors do not produce air pollution or carbon dioxide while operating. However, the process of mining the refined uranium ore and making reactor fuel oil require large amounts of energy.
Nuclear power plant involve fission reactions. There are 430 nuclear power plants worldwide. 40% of world's electric energy is generated by nuclear power. United States of America produce more nuclear energy than the other country. To operate this nuclear power, we have to use uranium, which is rare earth metals. Uranium was discovered by Martin Klaproth in 1789. 40% of world's supply of uranium are from Kazakhstan. Nuclear energy is climate friendly and not dangerous, but the way it was generated will give us harmful waste product. Based on 3 incidents of nuclear power, it takes until 14 years to clean up the nuclear disaster.
1789, uranium was discovered by Martin Klaproth and named after planet Uranus. 1895 to 1945, nuclear fission was developed. Most development was focused on the atomic bomb. 1945, harnessing this energy in conservation for making electricity. 1956, evolution of nuclear power plants.
I want to talk about how nuclear energy works. This picture shows the process how electricity can be generated from uranium. Nuclear reactors are the heart of a nuclear power plant. They contain and control nuclear chain reactions that produce heat through a physical process called fission. That heat is used to make steam that spins a turbine to create electricity. Energy released by the nuclear reaction heats water in the pressurized first circuit to a very high temperature. The nuclear reactor consists of 3 crucial components: fuel elements, moderator, and control rods. Fuel elements come usually in the shape of thin rods of about 1 cm in diameter and contain fissionable nuclei like uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. The place where these rods are located is called the reactor core. These fuel rods are normally immersed in water, which acts as a coolant and moderator. The moderator helps slow down the neutrons produced by fission to sustain the chain reaction. Control rods can then be inserted into the reactor core to reduce the reaction rate or withdrawn to increase it. Superheat water is pumped to a heat exchanger, which transfers the heat of the first circuit to the second circuit. Water in the second circuit flashes into high-pressure steam. A heat exchanger is a system used to transfer heat between 2 or more fluids. Heat exchangers are used in both cooling and heating process. The fluids may be separated by a solid wall to prevent mixing, or they may be in direct contact. Steam is directed against a turbine, setting it in motion. The turbine sets the generator in motion, then generating electricity. As the steam flows past a turbine's spinning blades, the steam expands and cools. The potential energy of the steam is thus turns into kinetic energy in the rotating turbine's blades. Because steam turbines generate rotary motion, they are particularly suited for driving electrical generators for electrical power generation. The turbines are connected to a generator with an axle, which in turn produces energy via a magnetic field that produces an electric current. A third circuit cools the steam from the turbine, and the waste heat is released from the cooling tower in the form of steam. After the steam is used to power the turbine, it is cooled off to make it condense back into water cooling tower system work by using water to extract waste heat from a system and injecting it into the atmosphere primarily through evaporation.
Radioactive waste is produced from the nuclear power stations. The nuclear fuel used contains uranium, which can be separated from the waste and reused, as well as the plutonium, which is a highly radioactive fission reaction created by the uranium nuclear fuels. New reactors that use these products as fuels have been constructed. Plutonium is used in the production of nuclear bombs and possesses a very serious threat if it comes to the wrong side.
Next, we talk about the worst nuclear power plant incident in history, which is Chernobyl nuclear power plant near the city of Pripyat in the north of Ukraine. It was caused by one of only two nuclear energy incidents rated at 7, the maximum severity on the International Nuclear Event Scale. The Chernobyl disaster was caused by a nuclear accident that occurred on Saturday, 26 April 1986 at the number 4 reactor in the Chernobyl nuclear power plant. The accident started during a safety test on an RBMK-type nuclear reactor, which was commonly used throughout the Soviet Union. The test was a simulation of an electrical power outage to aid the development of a safety procedure for maintaining reactor cooling water circulation until the backup electrical generator could provide power. This gap was about 1 minute and had been identified as a potential safety problem that could cause the nuclear reactor called the overheat. It was hoped to prove that the residual rotational energy in turbine generator could provide enough power to cover the gap. 3 such tests had been conducted since 1982, but they have failed to provide a solution. On this fourth attempt, an unexpected 10-hour delay meant that an unprepared operating chief was on duty. Upon test completion, the operator triggered a reactor shutdown, but a combination of unstable conditions and reactor design flaw caused an uncontrolled nuclear generation instead. 31 people died as a direct result of the Chernobyl accident, 2 died from blast effects, and a further 29 firemen died as a result of acute radiation exposure in the days which followed.
1:23:42. Perevoschenko looks down on the enormous steel lid of the reactor and sees the impossible. The control rod and fuel channel caps, which each weigh 350 kilograms, are jumping up and down. He runs to warn the control room, but there's nothing he can do to stop what is coming. 1:23:44. The steam blows more fuel channels apart. We do not know how high the power went. We only know the final reading. Reactor 4, designed to operate at 3,200 megawatts, went beyond 33,000. The pressure inside the core can no longer be held back. At long last we have arrived. 1:23:45, explosion. In the instant the lid is thrown off the reactor, oxygen rushes in. It combines with hydrogen and superheated graphite. The chain of disaster is now complete.